All right, so we are going to talk about simple inequalities. So an inequality is just anything other than an equal sign. So below are the four types that we use. The first one means, and this is like you're reading from left to right. So if that something's over on the left side, it's less than whatever is on the right side. So maybe like x is less than 8. Next one says it's less than or can also be equal to. So or being the big word right there. If I say x is less than or equal to 10, well, that can be 10, it can be 9, 8, 7, 6, 5, and anything on down forever. Next one says greater than. And the last one says greater than or equal to. Can't be both. It has to be either greater than it or equal to. So this one would be x greater than 3. X is greater than or equal to 15.1. So whatever you want to put in there. So again, that's always when you're reading from left to right. That's what those symbols say. A solution of an inequality is any number that makes the inequality true. So the big difference between an inequality and an equation is that in an equation we end up with one answer, x equals 5. Here, if I say x is greater than or equal to 5, we actually have an infinite amount of answers because 5 will work, 6 will work, 7 will work, 8.3 will work, 10.256 will work. We can go on forever all day naming numbers that are greater than 5 or equal to 5. So in order to show this, when you graph an inequality, which is just on a number line, not a graph, you show all of the possible answers that will make the inequality true using either an open circle or a closed circle. And we'll explain the difference. So down here we've got the phrase. We're going to write an inequality that goes with the phrase. So x is less than 7. So x is less than 7. So we're just pulling those symbols from up top. When I go to graph this on a number line, I'm going to start with, okay, here's 0. 7 is up here compared to 0. So everything less than 7 is going to be between 0 and 7, and then all the things that are less than 0, all the negative numbers. But it doesn't include 7. 7 is not less than 7. So on the number 7, just to show where we start, I'm going to put a mark, but I'm going to keep it open. I'm not going to shade it because that's saying, okay, starting at 7 but not including 7, all these numbers that I'm shading are less than 7. So basically 6.9999999 forever and ever, but not 7. And then everything down into the negatives. Next one, y is greater than 8. So again, we're going to start with our, just kind of, it's a pretty generic number line. You don't have to put every little mark in there. Same idea. So y is greater than 8. I want to shade all the numbers on the number line that are going to be greater than 8. So that doesn't include 8, but that's like our starting point. Everything just bigger than 8 though, and then keep going forever. So you're shading the numbers that make it true, the solutions. Next one, n is less than or equal to 4. And you'll notice there's another phrase here, n is no more than 4. Just another way to say that. So n can be all the numbers less than 4, but now they're saying, oh, we can include the number 4. That works also. So here's where 4 would be. So n is less than 4 or equal to 4. So I'm going to use a closed circle to show that, okay, I want to include the number 4. That is a solution. And all of those numbers less than 4. So just to, well, we'll do the last one. T is greater than or equal to 3. So, 3, oops, I reversed my colors. So I'm going to use the number 3 because that's equal to 3, so that will work, along with all of the numbers greater than 3. All right, so the top 2 had open circles on the actual number. The bottom 2 have closed circles on the actual number. If I'm given one to solve, we do this just like we do an equation. You have to isolate the variable first. So before you graph anything, get that W alone. So in order to get W alone, I have to do the opposite of minus 9 and add 9. All right, so W is now by itself because negative 9 plus 9 is 0. Greater than or equal to, and we all know that negative 30 plus 9 is negative 21. So on the number line, negative 21 is down here in the negatives. So everything that's greater than or equal to negative 21. So that's going to include negative 21. And greater than would be going on up to 0, and then all the positive numbers. Okay, next one. In order to get A by itself, I need to divide by negative 6. Now, I'm not going to ask you, don't write down anything yet. Just watch what I do. So if I leave this as A is, and I'm going to tell you right now this is wrong, that's why I want you to not write it yet, less than negative 4, then that means everything less than negative 4 should work. But if I put in negative 5 is less than negative 4. If I put a negative 5 in for A negative 6 times a negative 5 equals positive 30. 30 less than 24 is not true. So something's wrong. Back when we went to solve this and we decided we needed to divide by negative 6, you have to remember anytime you multiply or divide, so if you multiply or divide by a negative on both sides, you changed everything. So you need to flip the symbol. So when I decided I need to divide both sides by negative 6, that's automatically going to turn this into A is greater than, and then 24 divided by negative 6 is negative 4. And when we go to graph that, we have 0. I'm going to use an open circle because negative 4 won't work. If I put negative 4 in there, I get positive 24. 24 is not less than 24. But if I put anything bigger than negative 4 on up all through the positives, it will work. My answer will come out to less than 24. Last one. So I see D divided by 2, which means I need to multiply by 2. I am not multiplying both sides by a negative. I'm multiplying both sides by positive 2. So this does not apply. So D is going to stay over here. Less than is going to stay less than. Negative 10 times 2 is negative 20. So here's 0. negative 20. Negative 20 is not included, so it's an open circle. But everything that's less than negative 20